Welcome to Unintended Consequences, Episode 8. It's May 13th, 2026. This is a show about what happens when smart, well meaning people try to fix something and the world fixes back. In July 1960, Egyptian engineers began diverting the Nile at Aswan. They were laying the foundation for a dam that would finally tame the river's annual flood. The structure, completed a decade later, delivered reliable electricity and ended the centuries-old cycle of destructive high water. Yet within a few years, the same river that had deposited fresh silt across the valley floor each summer began to carry far less of it. Fields that had been fertile for 5,000 years suddenly depended on imported fertilizer. The Mediterranean coast faced steady erosion. President Gamal Abdel Nasser championed the Aswan High Dam as the centerpiece of Egypt's post-colonial development plan. After the United States and Britain withdrew financing offers in 1956, Nasser turned to the Soviet Union. The Soviet Union supplied technical expertise and roughly one-third of the project's cost. The immediate goals were straightforward. The dam would store enough water to irrigate an additional 1.3 million hectares of farmland. It would generate 2.2 gigawatts of hydroelectric power for industrial growth. And it would protect Cairo and the Delta from the catastrophic floods that had killed thousands in 1946 and 1954. At the time, planners viewed the Nile's seasonal pulse as an archaic liability, rather than an ecological subsidy. Soviet and Egyptian hydrologists calculated reservoir capacity using records that stretched back only to the late 19th century. Those records began when British engineers started systematic gauging at Aswan. To leaders facing rapid population growth and the memory of wartime food shortages, a single concrete barrier that could store 2 years of average Nile flow appeared to be a rational, modern solution. Construction began in January 1960 and continued through the Six-Day War and Nasser's death in 1970. The completed dam rose 111 meters above the riverbed. It created Lake Nasser, which stretched 550 kilometers into Sudan. Early performance data released by the Egyptian Ministry of Irrigation showed that downstream water levels could now be regulated within a few centimeters year-round. The first turbines began feeding the national grid in 1967. Official statements at the 1971 inauguration celebrated the dam as the foundation of a new industrial Egypt. A small number of foreign observers, including a 1962 paper in Nature by biologist Julian Huxley, warned that trapping sediment would alter both soil fertility and coastal dynamics. These cautions received limited circulation inside Egypt. By 1973, the reservoir had reached its design level. Egyptian officials reported that flood damage along the main Nile Valley had essentially ceased. Once the dam closed, the annual flood that had carried an estimated 124 million tons of nutrient-rich silt to Egyptian fields each year was reduced to a trickle. Farmers responded by applying synthetic fertilizers at rates that rose from roughly 50 kilograms per hectare in 1965 to more than 300 kilograms by the mid-1980s. This change increased costs and contributed to soil salinity in poorly drained areas. In the Mediterranean, the sardine fishery centered on the Nile's nutrient plume collapsed. Landings off the Egyptian coast fell from approximately 18,000 tons in 1962 to fewer than 500 tons by 1968. Coastal currents, no longer replenished by sediment, began removing shoreline at rates of 20 to 30 meters per year in parts of the Rosetta and Damietta promontories. This erosion threatened villages and agricultural land that had been stable for centuries. Stagnant irrigation canals and the perennial flooding of fields created ideal conditions for the snail-borne parasite that causes schistosomiasis. Prevalence in some delta districts rose from 5% before the dam to over 30% by the late 1970s. Lake Nasser itself became a new fishery, yet the economic gains there did not offset losses felt by Mediterranean fishing families. The causal chain was direct. By interrupting the river's sediment transport, the dam severed a 5,000-year link between upstream erosion and downstream fertility. It forced Egyptian agriculture onto an industrial input treadmill. It simultaneously exposed the delta to marine forces it had previously resisted. By the early 1980s, Egyptian authorities had launched a national drainage program. They began subsidizing fertilizers to compensate for lost silt. Coastal protection works, including groins and beach nourishment, were installed at several hotspots. These structures sometimes accelerated erosion farther along the shore. In 1992, the government introduced a policy allowing farmers to sell water rights. The policy was an attempt to improve efficiency. It also created new disputes over allocation during drought years. Lake Nasser continues to supply roughly 55% of Egypt's electricity. It supports a reservoir fishery that yields more than 30,000 tons annually. Yet, the delta's land loss rate remains a concern for planners. Sudan and Ethiopia have since built their own upstream reservoirs. These projects further complicate sediment and water sharing agreements that were never fully resolved after the 1959 Nile Waters Agreement. Complex natural systems often deliver multiple services through the same physical process. When one service is optimized, others can disappear without anyone intending the loss. Decision makers therefore benefit from mapping the full material flow, sediment, nutrients, water, before intervening at a single point. The Aswan case also shows that once a large infrastructure project is in place, subsequent adaptations tend to add cost and complexity rather than restore the original balance. Today, as countries consider new dams on sediment-heavy rivers from the Mekong to the Colorado, the same question recurs. What will the river stop carrying once we teach it to stand still? That wraps today's case. The lessons travel further when you share them. Send this episode to someone who'd find it useful. We'll see you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.